Good day, dear friends. Hope all of you are fine. I'm Pranasish. I'm back to help you how to get average velocity and instantaneous velocity in position time graph for rectilinear motion. Let us at first learn how to find average velocity of a particle in the position time graph. This is the position time graph showing the different positions of a particle at different instants. The particle moves along a straight line. O is a fixed position or fixed point with respect to which the particle's different positions will be measured at different instants. Here we see that the curve is directed upward, and it means that the particle moves in the positive direction, and the curve touches the positive side of the position axis, and it gives us the hint that the particle starts from a point which is located on the positive side of the fixed point O. The position of the particle with respect to the fixed point O at the instant t equal to t1 is x1, and the position of the particle with respect to the fixed point O at the instant t equal to t2 is x2. Thus the interval from t1 to t2 is delta t is equal to t2 minus t1, and the displacement of the particle over this interval is given by delta x is equal to x2 minus x1. Let us now recognize delta t and delta x in the graph. This is the instant t equal to t1, and this is the instant t equal to t2, and capital T1 is the point corresponding to the instant t1 on the time axis, and t2 corresponds to the instant t2 on the time axis. The points corresponding to these two instants on the curve is p1 and p2. Thus t1 p1 is equal to x1 and t2 p2 is equal to x2, and the particle's position at the instant t equal to t1 is x1, and the particle's position at t equal to t2 is x2. Thus the displacement over the interval delta t is equal to x2 minus x1 is equal to delta x. Let us draw a perpendicular to p2 t2 from p1, and the perpendicular touches p2 t2 at S. t2 p2 is x2, and t2s is equal to t1 p1 is equal to x1. Thus sp2 is equal to delta x, and p1s is equal to t1 t2 is equal to delta t. Now let's define the average velocity of a particle. The average velocity of a particle is defined as the ratio of the displacement to the corresponding interval. The join of P1 and P2 is the corresponding chord, and the chord makes an angle theta with P1s, that is the positive direction of the time axis. as P1s is parallel to the time axis. P2 P1s is a right angled triangle. Delta S is a right angle. Now, the average velocity V average is equal to delta x upon delta t is equal to, in place of delta x we can write sp2, in place of delta t we can write p1s, and from this triangle we see that sp2 divided by p1s is equal to the tangent of the angle theta. Thus, the average velocity of a particle in the position time graph is the tangent of the angle that the corresponding chord makes with the positive direction of the time axis. And tan theta is known as the slope of the chord. Thus we can write the average velocity in the position time graph corresponding to 2 points on the curve obtained or over a given interval is equal to the slope of the corresponding chord. So we write V average, or the average velocity, is equal to the slope of the corresponding chord. Now let's learn how to find the instantaneous velocity in the position time graph for rectilinear motion. This is the position time graph, and this is the curve obtained for a particle's position. Let us find the instantaneous velocity of the particle at the instant t is equal to t. P is the corresponding point on the curve. The instantaneous velocity of a particle is defined as the instantaneous rate of change of position of the particle with respect to time. Mathematically, we can write V is equal to, the instantaneous velocity V is equal to limit delta x upon delta t when delta t tends to 0. Let the corresponding point on the time axis be capital T. Now let's take another point, t dashed, and t dashed is so close to t that t dashed tends to 0, or delta t tends to 0. Let the point on the curve corresponding to t dashed is p dashed. The join of p dashed is chord p dashed. But chord p dashed is not identifiable as delta t tends to 0. If we produce p dashed on both sides, we get the tangent drawn to the curve at point P. And let this tangent make an angle theta with the positive direction of the time axis. Now, carrying the idea of the average velocity in the position time graph, we can say that the instantaneous velocity in the position time graph corresponding to a point on the curve or at some instant is the slope of the tangent drawn to the curve at that particular point. Thus we can write the instantaneous velocity v is equal to the slope of the corresponding tangent. In the next video, we'll see how velocity changes at different points along the same curve. And wait for that. Thank you.